Hi, I'm Ben Lorica, and I'd like to welcome you to the research panel, our second year in a row here at the Data Science Summit in Tel Aviv this year. So I'm going to start by doing a one-line intro of each of our panelists. So we have Professor Shie Mannor of Technion University, Dr. Amitai Armon of Intel, Dr. Kira Radinsky of eBay, and Dr. Aya Sofer of IBM. And I'm going to just jump right into a few questions that we prepared in advance, and then we'll try to leave some time so that you folks can ask questions of our panelists. So I think what I'll do is I'll have each of you start by describing the type of data science work that you are doing in your respective groups. So let's start on this side.
Sure. So I'm a reinforcement learning guy. Basically, we'll take data, we analyze it, and we figure out how to make better actions.
That's a really brief introduction. Okay. So I'll try to be brief as well. I'm Amitai. I'm the Chief Data Scientist of Intel's Advanced Analytics Group. And what we do is introducing AI, deep learning, and machine learning into Intel's operations and products. So we teach the machines in the factory how to personalize the work for each processor based on its history. We tell the processors how to personalize what they do based on the software that runs on them. We tell the salespeople how to sell the processors, who to call and what to offer, and so on. And we present today various projects that we have that use reinforcement learning and deep learning. We also have a nice collaboration with Professor Mannor sitting here.
So I'll be less short. So I have two lives. One of them is very commercial in eBay, and one of them is very academic in the Technion. So if we're talking about my commerce life, what we found out in eBay is that we have 1.5 billion products, but nobody actually spent any time to actually write any type of description about them, which is very problematic, especially if you search for them online. So how will you ever find a product that nobody wrote a description on? We're actually losing billions because of that. Well, one of the first things a company starts doing is, well, maybe we'll do it manually. So how many can you do manually? 100,000, 200,000? So a lot of the work we're doing today is, how can we generate descriptions automatically like a human being, like a seller would do, for people to find it useful? I can think about other things. Why not make personalized descriptions? Why a description should be the same for me and for you? How can we understand your very specific character from the way you're buying and adapt the content to only show the features of the product you care about? How big is it? Maybe how sustainable it is. Maybe you're a very colorful person. You only care about that you're the only one that has this product. There's a lot of field of study here about natural language generation in a commerce site. And probably we're doing a lot of game theory and price prediction. We actually realized that, well, you need to understand the real price of things. But that's really hard to do automatically. So we're doing lots of machine learning to predict what is the right price of a product, because it changes. And that's funny, I never knew this before I reached eBay, is that it changes on an hourly basis, the fair price of a product, depending on the demand that we have. And what we're doing in eBay, we're actually subsidizing many of the products so you can have the fairest price and still keep the seller happy. So this is a lot of my commerce life. In the Technion, I'm focused on healthcare and pharma. One of the really interesting things I've noticed is that you all know Moore's Law. Every year, technology is smaller, cheaper. In pharmaceutical, we have exactly the opposite. Every year, developing a new drug takes twice the amount of time and twice the amount of money. It doesn't get to a really good situation very soon. So a lot of the things we're trying to do is think, how can we create drugs automatically? A lot of the work we're doing, we're working very closely with Israel HMOs. So we're working very closely with Maccabi. And we have data about millions of people for the last years. We even have information for the last 20 years. And we're looking at interesting concepts like, well, maybe if somebody took this drug and it helped their diabetes, although the drug was intentioned for hypertension, well, this my drug can be a really good drug for diabetes that nobody knew. So this is the concept of drug repurposing. The problem is, well, doctors don't want to do clinical trials based on some correlation I found in the data. I completely trust them. They want to understand the biological process behind it. So we build systems that actually read medical articles and try to explain the automatic discoveries that our system is making. And the latest work that we've been doing right now is actually generating molecules that have high probability of being drugs. And what we did in a lot of our retrospective studies, we ran it on all the information humanity had till the 30s, and we're trying to recreate drugs. So in this retrospective experiment, we created 1,000 molecules, out of which 35 are already known drugs. And this is a lot of the future that I see in healthcare. A lot of the things that are being done today by biologists, chemists, are very manual works of pattern recognition. Some of them are supervised, some of them are unsupervised. And a lot of development that we're doing today is how can we automate lots of this work? How can we build an automated cardiologist, radiologist, as you've been seeing in many of the companies today?
Okay. So I will, again, in my role in IBM, I'm the head of what we call AI Tech in IBM Research worldwide. So we do a lot of things, and I will not try to cover everything we do. But fundamentally, I would say we're doing two things. One is we're trying to advance the state of the art in terms of the core technology. So let's just take language as an example. Whereas one could argue, even this is not exactly accurate, that in images, in many tasks, the computer is at the level of people. Language, we're very far from that, and I think you saw in the morning some examples from Yoav and so on. So we are looking at many, many approaches in terms of how we could actually get to the point that the computer would be able to understand language as we do. We do overall believe that this is probably some combination of deep learning, reasoning, knowledge, modeling, and so on and so forth. So that's a big part of what we're trying to do. I'll just mention one of the applications, which again, if you were here in the morning, you may have seen just a little bit of that. This idea of can chatbots really replace or somehow take care of a certain part of customer care automatically is something that many, many customers, it's like the Holy Grail. One of the telcos we work with, just as an example, spends $1 billion a year on customer support. So as you can imagine, they want to be able to automate part of it. So that's the good news. And the bad, maybe it's the good news for us researchers, is that we are very, very far from automating this. So the systems today require a lot of work, a lot of manual, human in the loop. We saw examples, and we are working on neural methods, knowledge-based, goal-driven, many, many different approaches to be able to, as an example, just take the human-to-human logs, because most of these already have hours and hours and hours of human-to-human logs, and can we take that? And out of that, start to generate better bots that would work out of the box. And again, just one example of many.
I just want to add that in today's conference, for those of you who are interested, you can hear 2 talks about things that are done in our department. So right after this talk, there's a talk about deep learning for validating graphical units. We let the computer automatically say whether videos and computer games look good when you run them on a graphical unit, instead of having people look at it and saying whether it looks good or not. And this morning we had another talk about reinforcement learning used for validating processors before they are in silicon, still at the simulator stage. And again, these are just 2 examples of many examples we have. We have a group of 120 people here in Israel analyzing video, text, time series data, lots of projects, lots of fun, and 9-digit value for annually for these projects at Intel.
All right, so next question is more of a free-for-all, no order. So you guys can mix it up, I hope. We had a similar panel like this last year. So just looking back over the last 12 months, did you find to be the most interesting or most important developments in data science? And like I said, whoever wants to answer in whatever order. I guess start with the professor.
Well, I think it's a tough question. To me, I didn't think there was any significant development beyond the overhyping. So basically, data science used to be a term that was somewhat, I would say, underused. Now it's overused. And I didn't see any significant sense. There are, of course, many small advances in many different subfields, but at least for me, there wasn't any single moonshot type of development except for the overhyping, which is, I guess, good for everybody here in the crowd.
So that's on the research side. What about, did you see any applications that were maybe not cutting edge on the research side that caught your attention?
Well, I think that autonomous driving has gone a long way. At least I saw some things that were pretty exciting, physically exciting. But nothing really caught my own personal eye. I think that we were very far in most fields, and I think that I mean the overhyping of the machines that are coming is just bizarre.
Well, I think that it's indeed difficult to tell what research evolvements that happened this year will be considered breakthroughs several years from now. Today, we think that, for example, LSTM is very important. It was invented 20 years ago, so it's very difficult to tell about the present. I think that there were some nice applications that caught my eye, like the AlphaZero Go machine that didn't have to get any rules from people, and the imitation learning in OpenAI that learned by itself. I think that another thing that is interesting is the ability to scale stochastic gradient descent in, for example, in training ResNet. So I think it represents some additional power that was not used so far. People usually didn't train on hundreds of servers, and now it's more widely understood that it is possible. But again, time will tell.
So I think one of the main problems that we're seeing a lot in the natural language processing world is the lack of data sets. Well, I can do whatever you want. I can use deep learning, I can use supervised learning, whatever you want, if I have the data set. The problem is building a data set for example, for every emotion a human has. First of all, let's define an emotion, right? And then building a classifier that identifies it is becoming a really hard problem. And then what we see more and more is that companies that are bigger and have more funds can actually recruit the people, build the data sets, and build better algorithms. And what I've started seeing the last year is actually algorithms which are independent of the data set. And I'll give one small example and a little bit from my experience in this field. So what we've seen is a really nice application where the researchers were trying to predict an Amazon review from a 1 to 5. This is a really large data set. As we all know, it's not human labeled, it is labeled by us, so it's kind of a distant supervision kind of space. But what they identified is a single neuron in the network that we're building. This neuron was really good in sentiment analysis. When they were applying it on all the data set we had on sentiment analysis, it actually reached state-of-the-art results. And this is really cool if you think about this. We were training an algorithm for one cause, and then identified a neuron which was trained completely, well, we might even say in an unsupervised way, for a completely different task. And I think this trend is something that we should definitely consider about how we scale a lot of the learning processes. Many of the things we're talking about, hey, let's build a human being in some way. So many people are thinking it's going to be a multitask scenario, because a human being, we don't learn how to read and then how to write. We kind of learn it simultaneously, and we see things and we hear things simultaneously. And this is how we perceive the world. So being able to teach a machine many tasks, all of them together, and actually breaking them down and understanding which parts are doing different things, it's a major development, at least in the applicative world.
Okay, I will, first of all, answer Shie. Again, I don't know if this is this year or not this year, but I can tell you there are many, many applications today of machine learning, data science, AI, or whatever we want to call it, that, even just in the enterprise world, such as, helping salespeople, prepare for meetings, or optimizing, their yield in sales and things like that, or HR, again, is another area where, again, I just know inside IBM we have many, many of these projects. So I think I'm a little bit more optimistic than Shie, although I totally agree that it's overhyped and the computers are not going to take all our jobs and so on and so forth. But I do think we're seeing more and more success stories. I would say the most interesting thing, though, for me this year is not necessarily yet a technology, but I think it is the fact that we are now beginning to talk a lot about bias in AI. So I think the whole area of ethics and the awareness of ethics in general, but in specific, I would say in AI, around this whole area of bias. And I think that is an artifact of the fact that indeed there are some AIs being deployed, and we see what the effect is if they're not trained properly, if they are trained with our biases and so on. So I do think that's something that we're seeing more and more, and I believe will make an impact over the next few years.
Yeah, I want to make a point here that I mean, my colleagues here didn't give any examples of anything that is really significant in the algorithmic world. So I think the field is losing steam in terms of development of algorithms. It's gaining a lot in terms of effect on the economy and society as a whole, which is great. But from the perspective of a professor, there wasn't anything new in the last 2 years. In fact, if you go to ICML, if you go to COLT, lots of papers, lots of work, lots of good work, but there wasn't any significant newcomer that you would say, wow, this is really going to change the field. And maybe we'll see once something like that, in ICML in Stockholm, but I'm doubtful.
So I guess following up on your point, Shie, so what are the challenges facing the field? Why isn't there much innovation? So a friend of mine describes machine learning in many ways as like searching this large space of algorithms, and he describes our current state as everyone's just searching this little corner around deep learning. So what will it take to get people to examine other approaches?
I think it depends on the field. In some fields, like finance, people are doing a lot of other things as well, because the data regime is just different. There's not that much data. Also in healthcare, much of healthcare. So I think for me, the next breakthrough can come from many places. Maybe causality is the next brick to fall. That is understanding what causes different things. Maybe it's going to be deploying RL to the masses. There are other different possibilities. I think that essentially research is a random walk. Nobody knows where it's going to take, and you have no idea where the next breakthrough is going to come from.
I think that the main challenges are related to the nature of the breakthroughs that we saw so far. So the breakthroughs in the recent years were around using a lot of data with lots of labels and building large models. And these are not all the use cases you have, right? For example, in our company, when we need to make a processor learn the software that runs on it, it has very little data, right? It has to make decisions in real time in a very different scenario than the scenario of identifying cats and dogs, right? And you can't put a big deep learning model on that processor, right? And the same for other cases when the machine needs to understand whether some processor needs more testing. We have very few examples of processors that have defects, right? Because our manufacturing is really good, so we don't have that many labels. Maybe we have just 10 examples of the defect, and we need to learn from it. So the actual challenges in the industry in increasing the impact of AI are around using less data, less labels, and seeing the same great results and same breakthroughs in real-world scenarios that are more abundant than those that the big companies have.
So I'll actually continue the same idea and talk from more of a personal view on this. We're trying to build a cardiologist. Well, it seems like a very simple problem. Since the 80s, everybody were trying to have an EKG and say the type of arrhythmia that we have. You would think that we already have so much data that we all can use this. But eventually, the data that we have is for 45 people. The problem with EKG in general is that the variance in their cardiogram, even in the same person, is so high that training a real machine learning algorithm on top of it is super hard. So while talking about the era of big data, there might be lots of data, but eventually labeled good data that we can train a lot of the supervised algorithms is very sparse. And this is where I'm starting to think about how can we generate data in a very good way. It doesn't have to come from people in a labeled way, either mining the data sources that we already have. And I'm a real believer that using a lot of the statistical methods and not using the simulators that we already have for many of the parts that we have is actually a big loss for the community. I'll give you an example. The heart is just a pump. We already have equations pretty much simulating lots of its processes, and it's still not being used correctly in a machine learning algorithm. From somebody who's been working a lot in the healthcare, we don't have a simulator of the body. That's pretty much insane. If you think about this, it's like flying a plane with 300 people on it and saying, well, if it falls, it falls. Well, all right. And we'll run by trial and error. But we don't have any simulation of a real body. Very few processes. Everything is in the doctor's head or maybe the biologist's head with almost no knowledge sharing in what we call kind of a Turing complete kind of way. And what I think could be the next challenge is kind of bringing an era where machines are teaching machines. I was asked once, how do I see the web as the next step? So if we're thinking about it, we had the web pages, then we had web service, and then I'm starting to think is that we're going to have lots of machine learning applications, learning from other machine learning applications. Then we need to think about how you build kind of an economy on top of this when you create a new type of application. Elon Musk had a really interesting saying about this, is the fact that, well, now that everybody's going to have an autonomous car, eventually each one of us is going to be a professional labeler, right? You're going to make mistakes. When you do something really well, the algorithm is going to learn it and then teach another machine based on your mistakes what to do. So this is how I imagine this, when we start building kind of algorithms in scale and making them learn either from simulations. This is actually mimicking completely the physical state of many of the processes that we already know, or build from different statistical data that machines are learning and know how to teach the other one.
Okay, so I think back to your question on challenges. So I think there's a few things. One is I think there's been so much innovation, and as we were just talking, we're trying to absorb it, and I think that's part of it, at least on the industry side. And at least when we talk to companies, you see the challenges in just taking simple things and making them work. And as a result of that problem, when you want to deploy, I think to some extent, maybe there's a little bit of saturation, and it's like the classic hype cycle, and we now need to get the things that we know how to work. That's I think on the practical side. On the research side, I think one of the things that I see is, and again, this is maybe this trend of instant gratification of the younger generation. So I see a lot of people are trying to solve the problems that we're already pretty good at, but just trying to beat more. We're already on, let's take an example, dear to my heart, squad, which is, this question answering. We're already at 90-something, 89%, which is 90, which is basically human level. But, there's a whole competition. Now Google does 130 layers and get it up there and, increases by another point. But there are much, much harder problems, as in reading comprehension, many data sets out there. They're hard. They're very, very hard problems. We're at 30%, 40%, but they're hard, and it's very hard to get better at them or to get to a level. So I think, people are there's this trend of just, beating by small points on these tasks that are well understood, and we need to somehow get more people out there trying to do the things that seem impossible, like I was saying before, totally automatically generating dialogue and things like that.
So this is our 4th year of this conference. It keeps growing, and there's a lot of other data science meetups and communities here in Israel. So what else should the local community be doing in order to nurture and grow data science and AI in Israel?
Well, I think data science and AI has grown quite a bit. What probably has to happen is that there should be dedicated, from an academic perspective, dedicated degrees in data science. We're starting to see some of them coming online. Probably should be more research centers. The government and industry and academia should join forces in building larger projects. I don't think that we need a moonshot just yet, but I think we do need several larger projects that would entice people to work on different difficult problems. I do agree with the immediate quick gratification comments that Aya made. The way things work is that if you want to get ahead in life, at least in academia, you need to publish. And to publish, you need good results. It's always easier to compare that I just got 2% more in some problem than to invent your own problem. So we as a community and my friends here from industry should be leading that. Should give data, should give problems, should try to canonize what are the important problems that are to be solved. So for me, at least, it's a joining of forces from academia, industry, and government together. I think that would make the most benefit. I think we have already enough meetups, so I don't think we need another one with this time 2,000 people.
So I think that in general, Israel is in a relatively good position. When I look at our company, the data science work of Intel is done mostly in Israel, right? We have, as I said, a group of 120 people that solves Intel's data challenges and takes all the types of data that Intel has and crunches it. And I'm sure that for Kira and Aya, it's quite the same in their companies. But still, AI is not as strong in Israel as cybersecurity, for example, and I think we should change that because cybersecurity is something we already know about, right? It's a problem that already kind of reached its peak, maybe, and AI is something that is going to reach a peak in the future, I think. So I do think that we need to invest more in training people, in teaching them data science. The government is doing some programs around that. We're also helping and teaching data science in Tel Aviv University. I do think we need to have some strong conferences. This is the reason why we co-organize this conference for the 4th year, because I think it is needed. And as Shie said, I agree. I think that a collaboration between academia, industry, and government is the way to make AI the next cybersecurity of Israel. We should have an AI park, and not just the cyber park and so on. And
AI week.
AI week, yeah, and make it as strong as cyber.
Perfect. So I'll just add what I was saying before is, well known the Israeli culture. Not everything starts from academia, not everything starts from industry. We do have a very strong body that actually helps cyber to become what cyber is, and this is, of course, the army. I think a lot of the efforts being done today, and this is, I'm very proud to say that there's been lots of progress in the last couple of years of actually growing real data scientists in the army, because they truly have, at least in the intelligence force and in other ones, truly have lots of data. Okay, they truly have the challenges, and people are extremely dedicated. Understanding how academia works with, specifically in Israel, with the defense forces and working with the industry is something which is not exactly solved, and we should definitely solve this faster so we can keep an edge in the data science field as well as we kept in the cyber. Another initiative that people here that are interested in is Israel decided that, well, they're going to promote everything to do with healthcare, personalized, ethical, etc. There's $1.5 billion shekels going to be invested in the next 5 years for collaborations between academia, industry, and hospitals. So hospitals are going to be actually incentivized to give their data in very simple contracts, both to the industry, that's going to be the first part, and the next part is going to be on academia to first create a personalized medicine applications for all of us, the citizens, and then creating additional applications so we can actually grow the data science and healthcare field from Israel and be leaders in the field.
Yeah, I don't know if there's much to add, but I totally agree. I think if we have unique data sets, and we do in the area of healthcare as an example, we're known worldwide because of the way the Israeli health system works. It's putting them out there and making these things available to people to use is going to be I think could help the whole community in Israel. And the other thing I could just say, talent, talent, and talent. We just need more people coming out of academia with the right skills. And I think we're all feeling the shortage. And in a small country, I think we have to make sure that we continue to have a good flow of talent for all these hungry companies for more and more people, talented people.
Yeah, and as someone who organizes conferences in North America, Europe, and China, I can say that I always look forward to coming here. And I think the more open Israel is with collaborating with the outside world and also helping solve problems outside Israel, I think more people will know about all the cool things that are happening here. And with that, unfortunately, we're out of time. So if you have questions, please feel free to approach our panelists. Thank you.